resistant for our anode because it has a high melting point, it also has a high atomic number. So we're able to produce high energy X-ray photons and a high number of X-rays as well. Actually, I think that's it.
Oh.
That's the end of this PowerPoint.
Get you a break for this.
Good job, Anthony. Good job.
So,
Great lecture.
In that case, it's time to review.
Yes.
But before we do that, any questions over what we covered?
Can you go over that one?
Well, so first of all, do we have any questions over the material we just covered? Yes, Cody.
So for it's talking about the increasing, like if you were going to increase the KVP,
Mhm.
so if you increase the mass by 2, the KVP goes up. No. KVP by 2, mass goes up by 4.
So if you increase the KVP, the intensity, the quantity
Yeah.
goes up, right? Not the mass,
Quantity, not the the
Right.
quantity.
but the quantity.
That was the word I was looking for.
Yes, Jay, did you have a question?
Generator types, the effective heat limits and things of that nature, are they the same as what we talked about prior, or?
They're the same generators that we talked about with heat units. Yes. Yes, Reagan.
So one more time, the half layer.
Half value layer.
Half value, that is associated with
Filtration.
filtration.
Mhm. Correct. Any other questions?
So, and beam quantity isn't mass. It's just the number of it.
Correct. Beam quantity is just the number of X-ray photons.
Okay.
So, correct. The setting you can control at the console, which is primarily responsible for quantity, is mass. So mass is your primary controlling factor. But mass and quantity are two separate concepts. Mass will control the quantity, but mass does not equal quantity.
KVP also controls quantity.
KVP can also affect quantity. Filtration can also affect quantity. Distance can affect quantity.
And then
So,
bremsstrahlung interactions are the most. They're the interactions that typically produce the most photons.
correct.
Yeah.
Very good. Any other questions?
You said KVP affects both?
KVP affects quality and quantity, yes. And you know that because if you look at the spectrum, goodbye, Mr. Phung. If you look at the spectrum, it moves in both directions. It moves horizontally and it moves vertically. So you know it affects both quality and quantity. Any other questions? All right, in that case, do you have anything prepared? Anything else? Well then, we'll do the normal Mr. Phung special.
Love it.
Yeah.
Now, before anyone has a heart attack or aneurysm, no, it's not a pop quiz. It's a pop test.
It's a pop exam.
Straight line is what? The blue line is what? That's good.
Like, so you're gonna
Okay, and then we'll see that.
Yes, the power level is
Yeah.
But for right now, all right, if you would focus, please.
Harvey was expecting him to reveal an Anthony shirt.
If the technologist or let's just say, if a change is made that causes the number of X-rays to increase, and the average energy of the X-rays to stay the same, what was the change? So, let's start with Reagan. What do you think? What do you think the answer is here? Okay, Carla, how about you?
Is it math?
What is that?
Is it math?
Okay, why do you think it is mass?
Because it's the quantity.
The quantity, where does it say quantity? The number of, alright, so yes, number of X-rays has increased. Number of X-rays is quantity. So we have a change in quantity, and a change was an increase. Okay, what about the second part of the question? So Reagan, let's have you, now that you saw how that works, what about the second part? Average energy of the X-rays stays the same. What does that mean?
What do you mean by that? I'm sorry, what's the question?
So, with number of X-rays increasing, Carla said that means the quantity increased.
Yeah.
So if the average energy of the X-ray stays the same, what does that mean? What is another word for average energy of the X-rays? If it's not quantity,
Quality of the quality of it. Sorry. Yeah.
okay, and what is happening to the quality of the beam?
It's staying the same.
It's staying the same, so is there a change
To the.
to the quality? No change to quality. So quantity is changing, quality is not changing. There's only one thing we discussed which shows this pattern.
Character.
So what can we change out of our, so think of all those emission spectrums we just looked at. Only one of them has quantity change but quality not changing. Only one of them has the height of the peak moving up and down, but not side to side. Not characteristic in Browns. Both characteristic in Browns are on the emission spectrum. But in general, looking at that spectrum, looking at the peak of that spectrum, only one thing causes the peak to go up without moving sideways.
Generator.
MA, it is mass. So Carla was correct. Right? MA, time, mass, right? All three of them all have the same effect, which is increasing quantity or decreasing quantity, right? Without changing the quality. So if we go back to our emission spectrum, and we jump over here to our MAs, right? The peak here goes up and down, so the quantity is changing, but it does not go left or right, so the quality does not change. Does that make sense?
But in the slide we just went over, it said it had like both of them underneath it.
Mhm.
Like KVP.
Correct. KVP and mass were both under quantity. But what about for quality? Which things were listed under quality?
KVP, mass, distance, and vibration.
Under quality, what do we see? KVP and filtration. Do we see MA? No. So does MA change our quality? It does not. But instead of having to remember all that, you could just memorize what this graph looks like. And just remember that on MA, the graph moves up and down, but it does not move side to side.
Yeah, but see, what I was remembering is how you said, okay, KVP is quality and then mass is quantity.
Correct. Those are the controlling factors.
Yeah, I know, but KVP is under both of them.
That's true, yes. So we just need need to take that one extra step
Yeah, but
and remember
it's
that
saying the energy
KVP.
would not change. So if you do increase the KVP, it's gonna increase the energy, and it's gonna affect the number of photons. So it's saying the energy did not change. So you do not,
So if the energy
it's not
were to
KVP.
change.
Okay. So yes, all right. So let's try a different one. If a change is made that causes the number of X-rays to increase and the average energy of the X-rays to also increase, what was the change? So let's see. Let's jump over here to Shamika. What do you think?
It'll be KVP.
KVP. So on our KVP graph, does the curve change vertically? Does our curve change horizontally?
Yes.
So if our curve goes, so let's see how I want to phrase this. All right, so number of X-rays increases. What change to KVP would cause the number of X-rays to increase? Does KVP increase or decrease?
It increases.
It increases. Very good. If KVP increases, does the curve move left or right?
Moves to the right.
Moves to the right. If the curve moves to the right, does that mean more energy or less energy?
More.
More energy. So does that fit our question? Yes. So KVP is one potential answer here. KVP will increase the number and increase the energy. What could a second answer be, Sindhu?
Can I look at my notes?
What is that?
Can I look at my notes?
You may look at your notes. So, any guesses, Sindhu?
No, Mr.
Johns, what do you think?
Filtration.
Filtration. All right, so what kind of change to filtration would cause the number of X-rays to increase?
Increase the filtration.
So if we increase filtration, what are we doing?
Increasing the average energy of X-ray.
That's right. Increasing filtration increases average energy of the X-ray. How does it do that? Why does the average energy increase if we add filtration?
It filters out the trash.
The trash X-rays. That's right, the low energy X-rays. It filters out the low energy X-rays. So what happens to the number of X-rays?
It increases, or it does decrease.
The number of X-rays decreases because you're getting rid of X-rays, right?
Mm-hmm.
So energy goes up, number goes down. Does that match the question? Does that match your question?
No.
It does not. So can this be filtration?
No.
No. So we need to look for something else. Let's see, I saw Cody with this hand
The
earlier.
generator.
Generator, very good. So if we hop back over, right, when we take a look at our generator, you see, with generator, as our generator type improves, our curve goes up, which means more X-rays. Our curve goes to the right, which means more energy. So generator would be another answer. Does that make sense?
Yes.
Okay. Let's try another one.
Cause you can like remember the curves by remembering like things that affect like beam quality and quantity, right?
You could.
So there's like KVP mass. The generator's not part of that per se, but
Mhm.
KVP mass, generator, and filtration. But filtration is part of quality? No.
But filtration will affect both of them.
Oh, okay.
Decreases.
Right.
Yes. So, Melanie, this one please. Oh, sorry, Samantha, did you have a question?
Oh, no, I was just gonna add to it. I think I was gonna do the final one.
Oh, okay. So, what do you think, Melanie?
What, I couldn't hear. What she's
Read it out for us.
So the changes make that causes the number of extras to increase and the average energy of extras to also
Oh,
decrease.
sorry, to just go on.
To decrease
Decrease.
what was decreased.
So if it's tall and everything.
So what's happening?
What is decreasing?
Oh, no.
So that's your.
This is,
Any guesses?
This is taller.
So what is the change though? What factor did you change?
what did I say, Melanie?
Oh.
So let's go through our different things. Name something that we could change. Mass. Okay. So how would you change mass to cause the number of X-rays to increase? What? How would mass change to cause the number of X-rays to increase? Did mass go up or down? Okay, so yes, if you increase mass, you have more X-rays. Great. If you increase mass, will that also cause average energy to decrease?
No, it would also
Does mass affect average energy?
No, it
It does not. That's right, throwing more ping pong balls does not increase your penetrability. So average energy does not change. Right, so does that match the question? Does mass fit this? No, it does not. Let's try something else. What else do we have? KVP, great. So what change to KVP would increase the number of X-rays? How would KVP change to increase the number of X-rays? Any guesses? If we increase KVP, do you think that would increase the number of X-rays?
Oh, so if you decrease KVP.
I don't know.
Angelica, what do you think?
Wait. Repeat that?
So KVP, how would you change KVP to increase the number of X-rays? Which way would KVP go to increase the number of X-rays?
Right?
Up or down? Would KVP increase or decrease?
Up.
Okay, yes. If we increase KVP, we increase the number of X-rays.
Yeah, that's what I was wondering.
So, if we increase KVP, we increase the number of X-rays.
Energy would also increase.
Correct. If you increase KVP, you also increase the average energy. So does that fit our question?
No.
No, so this cannot be KVP. What else do we have?
Filtration.
Filtration. All right. Cody. So with filtration, what change to filtration would cause the number of X-rays to increase?
You decrease it.
Great. If we decrease filtration, we get rid of less X-rays, and so we have more X-rays in our beam, right? So decreasing filtration increases the number of X-rays. If we decrease filtration, what happens to the average energy?
Probably goes, well,
Right, if we decrease filtration, we get rid of fewer low energy X-rays. So, we're
because earlier we talked about, we're trying to get rid of the useless stuff.
correct,
So that makes it stronger, like
Correct.
it's stronger energy.
correct,
So in this case, it's flipped,
correct.
so it should be a decrease.
Very good. So we decrease filtration, we are getting rid of fewer low energy photons. The low energy photons are staying in our primary beam. So our primary beam now has more low energy photons. So just like having more low grades brings your grade down, having more low photons brings our average energy down. Right? So average energy goes down when filtration goes down. So does that fit the question? Decreasing filtration, does that increases number, decreases energy? Does it fit?
Yeah.
It does. So this is a decrease to filtration.
Yeah, decreased filtration.
So let's say I started with 4 millimeters of aluminum. I drop that down to 2 millimeters of aluminum. Or I drop it down to 1 millimeter of aluminum. Or I completely remove it altogether.
I thought the aluminum was inside.
Right? But I mean, we can add, we're saying that, assume that we can add and remove filtration.
Oh.
Remember those added filters? Remember that added filtration, like the wedge and
Yeah, that's what I
the
was saying.
Yeah,
Okay.
so we can add it and we can also take it away.
Alright? So do you see how I could ask questions about those graphs?
Too much.
Or I could literally just give you an unlabeled graph and ask you about it. Right? I could, so for example, I could just pull out one of these graphs. Let me just do this in the background. Pull a couple of these.
That's how we all prepare for this. One like this, like that. So you don't fall down.
His is like way higher. Yours is like plus I'm just like way higher.
Alright, great. Alright, so, alright, I could just throw a graph in like this and ask you, what is going on here?
How do you know if you're going from bottom to top or top?
Alright, so I could ask you, if I'm going from the pink line to the green line, what changes this?
Decrease the number of X-rays.
What change have I made?
Increase in X-rays.
Yes, but what factor did I change?
Mass.
So, is this a mass graph?
Yes.
He's looking like
No,
him.
it's not.
Without those bits in the boxes, how can you tell?
So, is this a mass
But it also
graph?
went left,
It increased and then it also went up.
and
Or
it
we went-
decreased the energy.
We're going from, are we going from purple to green?
Pink
Or are we
to
going-
green.
So, yeah, it's going from pink to green. So, peak,
He said, man, we're doing that on my
peak. And then on the other end, I've got peak. So, looking at the peaks of these graphs, did they change vertically?
Yes.
Did they change horizontally?
Yes.
So, can this be mass?
No.
Why not?
Because mass only affects the height. The amount.
It's not the energy.
Right, this cannot be MA because MA does not move left to right. The fact that there is this difference between our pink and the green left and right means that this is not MA. So, could this be KVP?
Yes.
Okay, why could this be KVP?
Increase KVP and decrease.
So, yeah, if you decrease, yeah.
All right, so let's say we go from pink to green. Okay,
Decrease KVP.
So-
Decrease KVP.
decrease KVP. So if we decrease KVP, Mansi, what happens to quantity?
The quantity decreases,
And what happens to quality?
decreases.
So quantity, which way is that? Vertical or horizontal?
Quantity?
Quantity. Great, vertical. So we can see that we went from pink to green. The quantity went down, the peak went down. So quantity did decrease. And which way is quality? Left and right. And which way did the quality go?
It went left.
Right, so pink to green, we went left. So the quality also decreased. So yes, this could be KVP. Does that make sense?
Yes.
Right, this matches what we know about KVP. Could this be filtration?
No.
Why not?
Because filtration.
Filtration is opposite.
Yes. Filtration is inverse, right? As quality goes up, quantity should go down, and vice versa. So, we should not have them both increasing or both decreasing together. So this cannot be filtration. Could this be target material?
Yes.
Yes.
Because if you decrease the atomic number, you decrease the number of X-rays and
Then
then
it'll
the
have
energy.
less of both.
So this cannot be target material.
Oh.
And there's a very obvious reason why. Take a look at your characteristic.
It's supposed to be, isn't it supposed to cut off completely?
Oh.
Or no,
Oh, yeah.
well, not complete. but-
So, do you see how the characteristic is in the same place, right?
Yeah.
What does that tell you about the K-shell binding energy?
That it's there for that one specific material.
Right, so the K-shell binding energy has to be the same for both of these, right? Both of these are gonna be 69 about for their binding energy. If we switch back and look at our actual graph over here for binding energy, for target material, what do you see is going on with our characteristic?
They're all
Too
in
much.
different places.
It's all over the place. You've got one here, you've got one here, you've got one here, you've got one here. Why?
Because each one has a separate amount they have to reach to make that.
That's right. Each material has its own binding energy, so each material has its own characteristic values, and they do not all match tungsten. Right? So here's whoops. Right? So here's tungsten's characteristic value. Different elements have different characteristic peaks. They're characteristic to that element. So no, this one here, they're in the same location, so this cannot be target material. Yes, Reagan.
Are we gonna have to know about binding energies for the different target materials?
You do not need to memorize the binding energies for different materials. All I ask you to memorize is K-shell for tungsten. But you do need to understand that K-shell for tungsten is specific to tungsten. K-shell for anything else is going to be different. And so that's why we know this has to be the same material, because it's the same characteristic energy.
Lord Jesus.
All right? So, now, do we have any questions?
After class.
After
It
class,
seems,
okay.
it seems confusing, but it's.
Alright,
It's not as
so
confusing as it seems.
let me ask you.
Yeah,
It's-
when he breaks it down, it seems so simple.
Yeah.
When he
We
asks
just have to,
questions, it's
we
like,
just have to
"Woo!"
look at it a lot. It will make sense. It's not that bad.
So let me ask all of you as a class, right? Because we are technically 1 day behind right now. There is a test scheduled for Friday. How many of you feel like you are prepared to take the exam on Friday?
Right now, as of today, but by the time Friday comes, I think I'll be okay.
Absolutely not.
Okay, how many want to turn Friday into our review and take the exam on Monday?
Is there a third option?
Me.
Is there a third option? The third option would be
Not
doing
taking-
the review on Friday, having a take-home test over the weekend, except the take-home test will be strictly timed to give you about 45 seconds a question.
Could be it.
Yeah, no.
Is it proctored?
Well, I don't need to proctor it because you're not gonna have time to look things up in your book.
Yeah.
You either know it or you don't, with 45 seconds a question.
Yeah, how work
That's the
okay.
point of 45 seconds a question.
I like the second option.
You underestimate my math skills.
So what you want to do is
We agreed on Monday,
So I think what we're gonna do is we will just push the test to Monday.
Alright.
And we'll